Hello students, welcome to Organic Embers. In this video, I am going to teach you how to convert the given reactant into product by using series of reagents. There are 15 reagents given here. You have to make use of these reagents and then do the conversion. And you are supposed to use strictly only 6 reagents. Whenever you come across such questions, you should be very familiar with the reagents, what exactly they do. For example, the moment you see this CH3COCl base, right? So you should know that it's a Friedel-Crafts acylation, right? And whenever you look at the product, right, see there is a deuteron. That means what? You should know that somewhere we need to use the D2O and D plus. That is nothing but deuterated water in acidic medium. And whenever you use NaNO2 dilute HCl, that means it's a diazotization process. That means you have to introduce NH2 group somewhere in the molecule. When you know this, only then you can solve such questions. For example, for this reaction, right, you have to introduce deuterium on ortho and para. That means what? With nitro, this is not possible because nitro is a meta-directing group. So you should know that you have to reduce this to an amine group. So how to reduce? We have to use a reducing reagent and then look for the reducing reagent. And the reducing reagent given here is H2 palladium carbon. Therefore, the first step of the reaction is reduction reaction. So what was the clue here? That we have to introduce the groups at ortho and para, but this is meta. So therefore, we are going to reduce this to NH2. So nitrobenzene to aniline is done by reducing reagents like you can do catalytic like hydrogen palladium carbon, or you can use lithium aluminum hydride also, but that's not given here. So let's use hydrogen palladium carbon. And what is this reagent now? P. And what is the value of that? 6. You write down that as well. Now, introduce some group at ortho and para so that you can substitute it by deuterium. You see what electrophilic substitution reaction we can do here. We can either do the alkylation or bromination. But for the alkylation, it's very difficult to break the carbon-carbon bond and then introduce the deuterium. But when you have bromine, it's easy. Therefore, I'm going to add bromine in water. And it provides a lot of Br plus ions, and this is electron rich and it is ortho para directing, right? So the bromine will go to ortho and para position. Right? So what is this reagent? So bromine in water is 4. So Q is equal to 4. That also you can write. So we are going to get tribromoaniline. Tribromoaniline. Now, we need to get rid of this NH2. It's very easy to do that. How to do it? Diazotization followed by H3PO2. So you should know how to convert aniline to benzene, bromobenzene, chlorobenzene, phenol. So it is all done through diazonium salt. That you should be always familiar. So the reagent I'm going to use here is NaNO2 dilute HCl at 0 to 5 degree cold condition, right? So it will form HNO2. So it will undergo diazotization. So N2Cl, the bromine positions are fixed, tribromo. Right? What is this? What is the number? So this will be R is equal to 5. So the third reagent, right? So R is equal to 5. Now let's get rid of the N2Cl. So how do you do that? Use the 13th reagent, H3PO2. So what is that value? S is equal to 13. So you are replacing it by hydrogen. If you don't write also, it's okay. So we got the tribromo now. Cool. How to convert this bromine to deuterium? You already have water in acidic medium, but it's deuterated, right? So we have to make use of this. Directly you can't do it, right? Because this acts as an electrophile. This carbon is also an electrophile, right? Positive charge. So how to do that? You have to reverse the charge on this carbon. How do we do that? Use magnesium in dry ether. That's called umpolung. That means you're going to make it opposite, right? The charge. How do you do that? By preparing a organometallic compound. Here the organometallic compound is Grignard reagent. So anyway, the reagent is magnesium dry ether, hence it will be number 9. So T is 9, right? So then what happens? All the bromine, right? They are going to be MgBr. It's not given whether it is 1 equivalence, 3 equivalence, right? So doesn't matter. You just can use any number of equivalents. So once we get this, just add the water D plus. So you see this will be negative charge, right? It will accept the proton. All the MgBr, right? So it will be replaced by deuterium like this, right? So here we have removed the nitro and then we have replaced the hydrogens by the deuterium. So it just indicates where the deuterium is going to, that is ortho and para position, right? So that's the reason we carry out such series of reaction to know the mechanism of the reaction. So anyway, this is the last reagent. So this will be what? U is nothing but 11. Okay, so it's not yet over. Just substitute the values here. So the P is, let me just write here, right? P is 6 plus Q is 4, R is 5, S is 13 minus, this is 9 and 11. So let me just add it here. So 9 and 11 would be 20. So solve for this. You are going to get the value as 8. Therefore, the final answer, the value of all this will be equal to 8. I hope I made this concept clear to you, and if you still have any questions, you can always ask me in the comment section. Thank you.